Solids, liquids and gases. You're familiar with the properties of solids, liquids and gases. Solids have a fixed shape and volume. Liquids take the shape of the container, but also have a fixed volume. And gases take the shape and the volume of the container. Solids and liquids have much higher densities than gases, as we'll see in this table. Lead, as a solid, has a density of 11,340 kilograms per cubic metre, not that much different as a liquid at 10,660, but only 1.2 kilograms per cubic metre as a gas at its boiling point. It's a similar picture with nitrogen, 1,026 kilograms per cubic metre as a solid, not far less than that at 808 as a liquid, but only 1.25 at STP, or standard temperature and pressure. More about this in a moment. And also with water. Water is actually more dense as a liquid than as a solid, but is still much less dense as a gas. Again, this figure quoted at its boiling point. STP, as I said, is standard temperature and pressure, which is 273 Kelvin, or 0 degrees Celsius, and 100,000 pascals of pressure. Conditions of a gas have a big effect on the density, and so we must state them. They have little effect on solids or liquids, so generally are not stated. It's the same molecules that make up the solid, the liquid and the gas, so these figures tell us that the spacing is similar in solids and liquids, but that gases have the particles much more spread out. Usually the solid is slightly more dense than the liquid, but there are exceptions, as we've just seen with water. We can calculate the number of water molecules in a cubic metre of ice, water and steam. First, to find the mass of one water molecule. Well, water, H2O, consists of 2 hydrogen atoms, each of mass 1, and 1 oxygen atom of mass 16. So it has a molecular mass of 18 atomic mass units, which comes out at 3 times 10 to the minus 26 kilograms. 1 cubic metre of ice has a mass of 920 kilograms, so it will contain 920 over 3 times 10 to the minus 26, which is 3.1 times 10 to the 28 water molecules. A cubic metre of water has the slightly higher mass of 1,000 kilograms, so it contains 1,000 over 3 times 10 to the minus 26, which is 3.3 times 10 to the 28 molecules, almost the same figure for the solid and the liquid. A cubic metre of steam, however, has a mass of just 0.59 kilograms, so it contains 0.59 over 3 times 10 to the minus 26, 2 times 10 to the 25 particles, less than 1,000th of that contained in solid or liquid. So as we've seen, gases have a density around about 1,000th that of the solid or liquid, and have about 1,000 times fewer molecules per cubic metre. This means the spacing between molecules will be about 10 times greater in gases, as 10 to the power 3, 10 cubed, is 1,000. The molecules in a solid are arranged in a particular order. This can be cubic packing, producing cubic crystals, something like this. We can assume the molecules act rather like spheres, and here they're packed end to end. Or even more closely packed in an arrangement called close packing, where here you'll see that one sphere fits into the gap between 2 neighbouring spheres. In any solid, the molecules are bonded to their neighbours, so they can vibrate around a fixed point, but they can't change position. In a liquid, the molecules are still close together, but now randomly arranged, with only very weak bonds between the neighbours. This allows the molecules to slide over each other and change position, taking the shape of the container, something like this. In a gas, the molecules are widely spaced, with no bonds between neighbours. They're free to move around and fill their container, something like this.